Hey, good evening, everybody. This is Ajoy ID 2230811. Today, my presentation topic is building an LSTM-based sequence model for text summarization. So, at first, we have going through what is text summarization. It is a process, intuitive process, where we have to make a large body of text into a shorter form and meaningful. So, there are mainly three types of text summarization. One is extractive summarization, which includes extract key sentences and phrases directly from the original text to create a summary. So, in this extractive summarization, we use text ranking, which is based on importance, TF, IDF, text rank, and we have feature extraction method as well as. Then we have abstractive summarization, which generates new sentence that convey the meaning of original text, similar how a human would summarize it. And the technique we use here, it is sequence to sequence model, LSTM transformer, and we use attention mechanism, which mainly calculates the weight and further, and it helps to predict the relevant word as well as until the summarization complete. So now we have hybrid summarization, mainly it is a combination of extractive and abstractive summarization. Now it's came to the question, why we use LSTM for abstractive summarization? Because LSTM resolves the problem of RNM, which is gradient vanishing problem. So it gives us better memorization and it is good for text summarization. So in LSTM, we have mainly 5 components. We have long term, mainly the whole text, all the relevant, irrelevant whole text. And then we have short term, mainly the relevant text, some text. And then we have forget get, which mainly remove the irrelevant text and input. We have mainly which word we are working with. And then we have output, actually the text we need it. So it has the advantage of handling long dependencies, sequential nature, memory mechanism. So some tools for text summarization, we have NLTK, spacing, TensorFlow Keras, high interest transformation. So now we have to give dataset overview. We have dataset, which is CNN Daily Mail news article dataset. Here is the link is given, and we get the dataset from Kaggle. So the dataset consists of 3 columns. We have ID, article, highlights, and we done pre-processing here. So model architecture, we have encoder, decoder, and we use attention mechanism, model details, input, output, and we have layers. And in model details, in encoder, we use LSTM, mainly which give us input sequence, mainly the hidden state and the cell state, which is further used for decoder. And in attention layer, we computed a weighted sum of encoder output based on the decoder current output, helping the model focus relevant parts of the input text to generate the summary. And we have to done concatenation to feed the final dense layer. So now training the model, we have loss function, optimization, matrix, and early stopping. So now we go to our model and we run our model in Kaggle. So first of all, we have import libraries, then we load the data set, and then we prepare the data, we tokenize, we create 2 token object here, then we feed the sequences so that the model learn the vocabulary from it. Then we have convert the text to sequences. We have pad sequences. Pad give us the length maintenance properly, sequence length maintenance properly. Then we have model parameter. We have a embedding diameter. Embedding diameter helps us to neural network and reduce the dimensionality. Then we have encoder. We have LSTM. Okay, it came up with a state, and then we have decoder. We feed the state here, and then we have attention mechanism. So the output of the decoder and the attention layer feed to the model, and we have the output layer where we use text. Then we define the layer. We use Adam optimizer. We have sparse categorically cross entropy, and then we have model fit, and we use 10 epochs here. And to avoid the overfitting, we use early stopping. And if we find the validation loss is consistent for 3, then we should stop our model training. and then we figure out our training, and after that we make an inference, and then using the model we generate the summary. So for summary we use sequence, we use tokenizing, then padding, and after that we making the process of generating the summarization until we reach to the end set token. So it is very necessary. And here we see we have 7 epoch, we have 7 epoch, and here is the performance visualization. Then we have explanation. As we see here, validation loss is stable around 80. So it is a sign of model is not overfitting, and it is generalizing very well. It is performance well in unseen data as well as. So we have sample output here. We have future work, for possible enhancement. We use pre-trained models like BART or GPT. An application, we know news article summarization, legal and medical document summarization. And then we have conclusion, future state, we can use that. And thank you all. If you have any question, let me know in the comment section. Thank you, everybody.